awful if you don't like proofs, but I will tell you that your homework tonight is not all proofs, and it's much, much shorter than the assignment that you had to turn in today, which was awful long, right? And I warned you that it was really long. Today is so much shorter, and it's not all proofs, so it's not going to be terrible. All right. So in chapter 4, we started it with proving triangles congruent by transformations. And I'm going to keep emphasizing that because I don't want you to forget when we get to the test. You can prove two triangles congruent on a graph by listing the transformations that make one triangle land on top of another triangle. Can a dilation prove two triangles congruent? No, it would have to be a reflection, translation, or rotation. So don't forget that. That will be on your test. But at this point, starting today through the rest of the chapter, and there are 9 sections, so we have a lot of sections still to go, we are going to be proving triangles congruent by writing 2-column proofs. Okay? So keeping that in mind, I want to also remind you, I think I put it on the assignment slip, not on this one, but maybe on the next one. If for some reason your question in your book or on your core math page says write a flowchart proof or write a paragraph proof, you are not going to do that. Remember, we talked about that back in chapter 2. Every proof we're going to do is going to be 2-column. So if it says that, you're going to go, nope, Lashley said change it to 2-column, and you're going to write a 2-column proof, okay? That way we're just real consistent, getting really good at that type of proof. Okay, so to prove polygons are congruent, which is our goal today. I'll come back to these in a second, but to prove polygons congruent, 2 polygons will be congruent if, number 1, their corresponding sides are congruent. And then I'm going to have you add, number 2, there's 2 things we're going to be looking for. Number 1, their corresponding sides have to be congruent. And number 2, their corresponding angles. Must be congruent. So to prove 2 shapes congruent today, you are going to prove them congruent by getting every corresponding side congruent to its matching corresponding side and every angle congruent to its corresponding angle. The reason we're going to learn this method, which is the longest way to prove triangles congruent, if you look at the board for the week, you're going to see that Wednesday and Friday we're still talking about triangle congruence, but we're going to learn shortcuts. The reason we're learning the long way today is because this works for every shape. It works for rectangles, it works for hexagons, it works for pentagons, decagons. What we're going to learn Wednesday and Friday only works for triangles. Okay, so we're going to learn some shortcuts specific to triangles, but today what we're learning would work to prove any shape congruent. All right, so what does it mean by corresponding sides and corresponding angles? Corresponding angles and corresponding sides are in the same position in the 2 polygons if they have an equal number of sides. So if I have 2 pentagons, the corresponding angles are the ones in the same position. The corresponding sides are the ones in the same position if you were to land them on top of each other. Okay, so if I have 2 triangles, how many angles are there? 3. How many sides are there? 3. That means I'm going to have to get 6 pieces marked and listed congruent in my proof before I can say my 2 triangles are congruent. The easy thing today about your proofs is that you only have one way to prove them congruent. When you prove them congruent, you're going to prove them congruent by this definition. Definition of congruent polygons. It's our only way to prove them congruent today. We've got to get every corresponding part matched up and congruent, and once we do, the 2 triangles or 2 rectangles, the 2 polygons are congruent. So every proof's going to end with definition of congruent polygons if you're proving the polygons congruent today. It's the long way, but it's going to be only one way to do it. Okay, but like I told you, not every problem is a proof today. So part of your homework is going to be to write what's called a congruence statement. They do not write this in your notes anywhere, so go ahead and add this statement here, and this statement here. You do not need the word polygon, so you can mark that out. These two things are called congruence statements. Congruence statements. Add that to your notes. So if they say write a congruent statement, they're asking you to name the two polygons that are congruent. Congruence statements. When you name them, you have to match up the corresponding parts. So if they give you a congruent statement, they are telling you which angles are congruent and which sides are congruent, just by looking at the statement. So for example, if I look at this statement, what angle is congruent to angle A? D. What angle is congruent to F? C. They are telling you which angles match up, which angles are congruent. They're also telling you which sides match up. Which side is congruent to AB? DE. Which side's congruent to CB? FE. So if you look at the statement, it is telling you which parts match up. They will purposely draw shapes to make you think they match up a certain way, but then give you a congruent statement that says they match up differently. You have to go off the statement, not what you think the pictures are going to do. Okay? This statement tells you exactly what matches up. So part of your homework is going to be easy. They're just going to simply give you a congruent statement and say, list all the corresponding angles. And so you will just list A's congruent to D, B's congruent to E, C's congruent to F. And then it may say, list all the corresponding sides. So then again, you can just look at the statement. AB's congruent to DE, BC's congruent to FE, AC's congruent to BF. And then you can list all of your sides that match up. Does that make sense? If you need to, you can draw yourself a picture and label it in order to write the sides and write the angles. Like I said, the great thing about this lesson is that it lets you prove any two shapes congruent. So if you look down here, you'll notice now we have two rectangles. Here's our congruent statement. And again, if they say corresponding angles, you're just matching all the angles. Corresponding sides, you're matching all the sides. And you can get that straight from the congruent statement. Any questions about the congruent statement or naming sides and angles? All right, so quiet. Okay, one thing that always catches students, to name a polygon, you have to write the vertices in consecutive order. For example, you can name polygon PQRS or QRSP or SRQP, but not PRQS. That's kind of hard to see without a picture, so let me show you what they're saying. If I draw a picture here, PQRS. When you name that shape, make sure you're going consecutively in a circle. So I can do PQRS, or I can start here and do QRSP, or I can start here and do SP, or they went this way, sorry, SRQP. Doesn't matter which direction, but notice what you cannot do. PRQS. That does not make a rectangle, right? So make sure that you are going consecutively, either clockwise or counterclockwise around your shape. All right, I already said this. The congruent statement tells you exactly which parts match up. Always go off your congruence statement. All right, so here's the first part that I was telling you that will be super easy on your homework. What is this called again? Congruent statement, and all they want you to do is identify all the corresponding congruent parts. So let's start with angles. What are my angles that are going to be congruent? Okay, first one I heard was angle P is congruent to angle S. Somebody different? What's another one? Thank you. Angle Q is congruent to angle T. Somebody different? The last one. Angle R is congruent to angle W. And then we'll list all our sides. So let's go, Joy. What's one pair of sides that match up? Just use your statement. Pick two letters that are in the statement. For example, PQ. That would be one side of your triangle. So I could say, oops, sorry, erase. I could say PQ is congruent to, and then what does PQ match up with over here? ST. Does that make sense, Joy? Okay, so PQ and ST would be one pair of sides. What's another pair of sides, Matthew? QR and TW, very good. So QR would be congruent to TW. And what's the last pair of sides, Weston? Okay. Okay, so which two letters have you not combined in the first triangle? Because it has three sides. PR. So PR would match up with SW. So if you need to, draw yourself a picture. Here's a picture, label it PQR, then draw another triangle and label it STW. Okay, so if you need a picture, draw yourself one, and then match up every pair of corresponding sides. But again, make sure you're doing it off of your statement, not just what you think they look like. Everybody good with angles and sides? Okay, so not a proof, just make sure you list everything in the problem. The second kind of problem you're going to see on your homework is something like this, and again, it is not a proof. It does say given some information. Again, what is this called? Congruent statement. But this time, they're asking you on the picture to do what? Find the value of x. So you're going to go to the picture. Again, I want to warn you, do not assume you know what matches up. Go off of the statement. So first thing I would do is find x in my picture. Here is where x is located with this expression. And what is it standing for? What's it pointing to? Angle ACB. So we know ACB, according to our congruent statement, ACB should match up with what? DCB. So always go back to your congruent statement. So DCB is how much? 90 degrees. So that means we can say 2x minus 16 should equal 90. And then from there, we're just going to solve for x. So add 16. 2x is equal to 106. And then what? Divide by 2. And so what is x? 53. It just said find x, and so that would be our answer.
On ours it says find.
I think that's the next one, right? Okay, so first one was just find x. Is everybody with me there? Okay, if you look at the next one down below and to the left, it's the same picture, but what does it ask you to find on the next one? Okay, the measure of angle DBC. So let's go to the picture. We're trying to find angle DBC. Sorry, one second. Mrs. Lashley? Yes. Okay, hold on one second. Bree, Jacqueline, and Marissa, phone, one at a time. Okay, guys, so I want to find DBC. First of all, what does DBC match up with according to this congruent statement? ABC, right? Do I know ABC? No. So how am I going to find ABC so that I can then go and find DBC? Very good, Marissa. We actually don't know this angle. Technically, we know X, right? X is 53, but we do know it should be what? 90, because we know that it's equal to 90. So yes, we do know this angle is 90, and we know that this angle plus this angle and this angle should all add to be 180. So Marissa said add 90 plus 49.3. What do we get if we add those two? Come on, guys, talk to me. 139.3, and then subtract that from 180. So we're going to borrow from the 8, make that a 7, that makes this a 10. Borrow from it, make it a 9, that makes this a 10. And what do we end up with? 40.7. So this angle ABC would be 40.7 degrees, but that also makes the angle we're looking for, since it's congruent to it, 40.7 degrees. Questions? Okay, I want to remind you of a shortcut that we learned last class period. We did not use it here, but it's going to help save you time if you would. Marissa had said to add these two and subtract from 180, which is perfectly fine. But remember, if it's a right triangle, what could we have done to make that a little quicker?
Subtract 49.3
Exactly. We could do 90 minus 49.3. We would still get 40.7. If this angle's 90, then the other two acute angles have to be complementary, which means they have to add to be 90. Okay? Any questions on that one? All right. All right, so on the next one, what are we trying to find? Value of x again. Again, this is where I would warn you, don't look at the pictures and just say, oh, I know how they match up. Go to your statement. Find x in your picture first. Here is x. It's on side AB. So then go to AB. What is AB supposed to match up with? DE. Go to your picture. What's the length from D to E? 6. So then it's easy. Then we can say those should be equal. 2x minus 2 should equal 6. And then solve for x. I just want to warn you one more time, never look at the picture and make your decision. Go back to your congruence statement, okay? So add your 2. 2x equals 8. Divide by 2, and x is equal to 4. And is that all it asked was for x? And then you're done. Okay? The other thing I want to warn you when you're looking at those pictures, if it's a side measurement, it will not have a degree symbol. If it has a degree symbol, then it's referring to an angle measurement. So when they're outside the triangle like that, typically they're referring to the sides, but if you're unsure, if it doesn't have a degree symbol, it's obviously not referring to an angle. Okay? It would have an arrow pointed in if it was referring to the angle, and it would have a degree symbol. Okay. So the next thing that we should see in our, the next thing you see is find the measure of angle F. Can I skip this since we've done several? Are we good with the concept, or does anybody need me to work this one? Okay, I'm going to skip this one so we can move on to some proofs, because this is going to be the harder part. So when you're working through your proofs, again, we're doing 2 columns, statements and reasons, and the only way we've learned so far today to prove 2 shapes congruent is using the definition of congruent polygons. And that definition says every corresponding side and every corresponding angle has to be congruent. So if we have 2 quadrilaterals, how many angles are there? Quadrilateral, how many angles are there? Yes, 8 total, but how many pairs of angles? 4. How many pairs of sides? 4. That means we would have to have 8 steps in our proof showing 8 things were congruent. How many sides are in a decagon? 10. So if I had a decagon and I was trying to prove 2 decagons congruent, how many steps would I have to have in my proof? 20. 10 angles, 10 sides. Do you think I'm going to make you prove decagons congruent today? You might after that assignment you just had to turn in, but no, you are not going to have to prove decagons. The most you would have to do would be a quadrilateral with 4 angles and 4 sides. Again, the reason we're learning this today, though, is so that you could use it for any polygon. Shortcuts we're going to learn next class period are only for triangles, okay? So most of your lesson is going to be about triangles because there's only 3 and it makes it a little quicker. We can do 3 angles, 3 sides. All right, when you work through your proofs, start with your statements and reasons columns. Did I give you a spot? Okay, good. So you already have yours set up. Let me set mine up real quick. Statements, reasons. Just a reminder with proofs that you will number each statement and number each reason. When you go to work your problem, my best advice is do not write all of your given down at once. Write one given down and ask yourself, what do I know from that? Then write the next given down, ask yourself, what do I know from that? Keep in mind that your goal is to get all 3 angles listed congruent and all 3 sides listed congruent. Okay, so first given is angle YWX and angle YWZ are right angles. Given. Mark your picture. YWX is a right angle, YWZ is already marked a right angle. That is not stating that they are congruent. That is stating that they are right angles. We had a theorem we learned way back in chapters 1 or 2 that said if they are right angles, then they are congruent. Does anybody know the name of that theorem? Okay, open your textbooks right now to the back where all of those postulates and theorems are. Remember, it's that sea green, teal colored section. Good, Jacob. Everybody find that section, though, because we're going to need it as we go through the proofs, and leave your book out on your desk in case you need it. It's going to be not the green section, but the kind of a bluish green. So, Matthew, keep going back further. It's the bluish green section. This is the best place to go when you're working on your proofs and you are not sure what the theorem is. Maybe you're like, I think we learned something like that, but I don't know. Or maybe you're like, I am lost. I have no idea where to go. Go and start reading through your theorems. Chapter 1, Chapter 2, Chapter 3. Be careful in Chapter 4 because there's a lot of theorems we haven't learned yet. So if you haven't heard of it, probably we haven't got to it yet. So it's not one you would use in tonight's homework, okay? So right angle congruence theorem says if two angles are right angles, then they are congruent. So the next thing we could say is angle YWX is congruent to angle YWZ. And the reason would be right angle congruence theorem. And I'm going to remind you, every year when I have students tell me they can't do proofs, it is not because they don't know to draw a two-column statement and reason chart. It's not because they don't know to number every step. It's because they don't know their theorems and postulates. You've got to take some time and study them. I mean, that's the only way you're going to be able to work proofs. If you're struggling, you have to know the name and what it says so that then you know what to use in a proof. Okay? So that's my advice. If you start to struggle, go back and study. Okay, so first given, here's what we can conclude. Got our picture marked. Now let's go on to the next given, number 3. Oops, sorry. Number 3. Back up here to our given, we have YW, line segment YW, bisects angle XYZ. Given. Be very careful with what that statement just said. Segment YW is bisecting what? Angle XYZ. What does it mean to bisect something? Split it into two congruent parts. What is being split into two congruent parts? Okay, according to this, what is being bisected is an angle XYZ. So that angle is being split into two congruent parts. So go to your picture. XYZ, that angle is being bisected by segment YW. What is being split then into two congruent parts, or what are the two congruent parts? Okay, I just heard two different answers from 3 different people. So I want to make sure, because I heard 2 of you say the exact same wrong answer. I heard XW is congruent to ZW. That's segments. That would mean you just split a segment into two congruent segments. But did it say that it was bisecting a segment? No, it is bisecting an angle. If you take an angle and you split it into two congruent parts, what shapes should you be getting? Angles. Two congruent angles. So it is this angle right here that is getting split by the line segment into two congruent angles. So it's those angles that we should be listing congruent. So one more time, what two parts would be congruent? Very good. Angle XYW should be congruent to angle ZYW. And I heard that from both of you. Good job. Very good, Ivan. Definition of angle bisector. To split into two congruent parts or to bisect is what we had to use to get that. So that was the definition of angle bisector. So if you're not sure why, ask yourself, how did I know? I knew that those were congruent because of that word bisects. And if it's from a word, that's because of the definition. Okay? Any questions so far? We've got it marked now. This angle is congruent to this angle. So right now we only have 2 angles listed congruent. How many parts do we need today if it's a triangle? 6. 3 angles, 3 sides. So we only have 2 so far. We still have to get 4 more. So go back to your given. W is the midpoint of XZ. Given. And then ask yourself, what does that mean if W is the midpoint of XZ? What do we now know? Okay, Weston, what were you going to say? Very good. Be careful how you state it, though. I'm going to be super picky that the parts match up all the way. So if you say XW, then you need to say ZW. So that when you were to fold those triangles, X lands on Z. So since you started with X, then W, I want you to start with Z, then W, just so the parts are always matching up. Does that make sense? But you are correct. So number 6, XW should be congruent to ZW. Always making sure your letters are matching all throughout your entire proof. What told us that those would be congruent? Okay, don't make it harder than it is. What word did they give us in step number 5? Midpoint. So how did I know that those pieces were congruent? The definition of that word. Definition of midpoint. I don't know how many times I'll have a student put definition of bisects right here. Did they have the word bisects in number 5? No, it doesn't come from a word that's not listed somewhere. So it's definition of midpoint. All right, mark your picture. So now we have 3 things listed and marked, and we still need 3 more. So we're going to go back to our given. Number 7. We have XY is congruent to YZ. That's actually not listed correctly. It should be XY is congruent to what? ZY. I want you to keep all the parts matching up correctly. So XY is congruent to ZY, and that is given. And then let's mark our picture. Mark, mark. Make sure you use 2 different marks there so that you're not using the same as you did on XW and ZW. So now we have 4 things listed congruent. This one was easy. We didn't have to conclude anything. They just gave us 2 parts congruent. So again, as you're looking through that proof, that's 1, 2, 3, 4 things that are listed congruent. We need 6. So now we've got to go back to things we've learned previously, either in this chapter or maybe even way back in chapters 1, 2, and 3. So what is something that's not marked congruent but should be congruent in the picture? Okay, YW. YW here is shared in both triangles. What tells us that YW is congruent to YW? Okay, but this has to be a definition, a theorem, a postulate, or a property. Reflexive property. Very good, Marissa. Number 8, YW is congruent to YW, and that goes back to reflexive property. Something is congruent to itself. So number 8 here will be reflexive property of congruence. Good, because it's whatever symbol you have in your statement, and it's a congruent symbol. Okay, so now that's 5. What's the other thing not listed in our proof that's the 6th thing that we need to be congruent? Angles what? Okay, so I could use 3 letters, but since there's only one angle at X and only one angle at Z, it's probably a little easier to just say X and Z. Why will those angles be congruent? Exactly. If you guys remember, last class period, we had a theorem, and I told you, you will use this over and over again next week. Third angles theorem. It said if two angles in one triangle are congruent to two angles in another triangle, then the third angles have to be congruent. And we have already listed two angles congruent. So now number 9, angle X has to be congruent to angle Z. And the reason I'm going to write way up here at the top for those of you in the back because I don't have room down here, that is the third angles theorem. There is no such thing as third sides theorem, so do not ever try to use that, okay? Are we actually done? No, we've got 6 things proven congruent, but remember our goal here is to say the two triangles are congruent, and that's your last step. So number 10 would be exactly what they tell us to prove. You should never miss the last step of your proof because it's always given to you what you're supposed to prove. So triangle XYW is congruent to triangle ZYW. Now your reason is not given. If it was given, there would be no proof to do at all. What is the only reason today that we can prove triangles congruent? Definition of congruent polygons. It's what we learned the very first thing on the front page of your notes. Definition of congruent polygons. If all corresponding parts are congruent, the polygons are congruent. Questions? I hope what you'll see is these aren't really hard because there's a procedure every single time. It's a little bit easier than some of the other proofs we've done, which are kind of like, oh, I don't even know where to go. There is a given procedure here. You have to get all 6 things marked congruent. Okay, let's try some more. Okay, and the more we do together, the easier the homework's going to be. So, again, I need a statements and reasons box. I should have given you one in your notes already set up for you. And again, my advice is do not write all of your given at once. It's going to make it easier for you if you'll do one given at a time, mark your picture, see what do you know from that given. So number 1, AD bisects segment BE. Given. These statements right here are the ones that a lot of times students get confused with. So I'm going to emphasize again. What is being bisected here? Okay, segment BE. AD is bisecting segment BE. If I take a segment and I bisect it, what 2 pieces should be congruent? Okay, I should get segments though, right? If you're bisecting a segment, you should get segments congruent. So what segment's being bisected is BE. So if I split BE into 2 congruent parts, what are my 2 congruent parts? BC and EC. And again, make sure you name it so they would actually match up, which you did very well there. So number 2 would be BC is congruent to EC. Where did that come from? Exactly. Segment bisector. And I won't count off, Ivan, if you say definition of bisects. It's just more precise to say definition of either angle bisector or segment bisector. In this case, it would be definition of segment bisector. But if you just put bisects, I wouldn't count off. It's just better practice. So definition of segment bisector, because we're bisecting a segment. Okay, so now we have one thing listed congruent so far. Even though the picture has red marks somewhere else, I need to use a different number of marks then. There's some red marks on the picture, but none of that's in our proof yet. So right now we only have one thing listed congruent. So we're going to keep going back up to our proof, to our given. Number 3, BE bisects AD. Given. So again here, what's being bisected? A segment, AD. So if we're taking that segment and we're splitting it into 2 congruent parts, what are the 2 congruent parts? AC and DC. So we're, yes, AC, DC. So number 4, we're going to put AC is congruent to DC. And what's the reason? Definition of segment bisector again. They told us it was bisecting, so we just go back to that word. Definition of segment bisector. Okay, so now we have two things listed in our proof. Go back to your given, number 5. They tell us that AB is congruent to DE, given. And it's already marked in the picture. I'm going to go ahead and mark it again, AB, DE here, so that we can see that we now have that listed in our proof. There's nothing to conclude from that. That's just some given information that says something's congruent. And then number 6, the last thing in our given is angle A is congruent to angle D, given. And again, I'm going to mark that, angle A, angle D. So if they tell you what's congruent, there's really nothing to conclude from it. You just mark your picture. If it's a statement about something in your picture, then what can you conclude from that? So now we have 4 things listed congruent, and we're missing 2 what? 2 angles, okay? So do you see any angles that would be congruent and have a reason for it?
Angle DCE is congruent to angle BCA.
Why?
The vertical angles theorem.
Very good. So be careful with how you named it, though. I'm going to come back to that. But is everybody with Anna that these 2 angles should be congruent because they're vertical? And the theorem was vertical angle theorem. Okay, Anna, you said angle DCE was congruent to. Now this is Lashley being picky here. If you're going from D to C, that's the side that had 3 marks on it. So when you name the angle DCE, what does it actually match up with? Okay, you want to go on the side that has 3 marks on it first. So don't say BC because that would be 2 marks. Do ACB because that's going to make the parts all match up correctly. Are you guys with me there? Okay, so DCE is congruent to angle ACB. And Anna's correct. That would be vertical. Make sure you're spelling vertical correctly. Vertical angle theorem. That's an E there for theorem. All right, so now we have, and I should have used 2 angle marks there, sorry, 2 arc marks. So now we're just missing 1 angle. What angle are we missing? Angle B and angle E. So angle B should be congruent to angle E, and what tells us that? Okay, again, Bree comes back to that theorem we learned last class period. If you already have 2 angles congruent to 2 angles, then you have that third angles theorem. Angle B is congruent to angle E, and the reason is third angles theorem. And now we have all 6 parts marked and listed congruent, and so we can go straight to what we're trying to prove. Triangle ABC is congruent to triangle DEC. And what's our only reason for that today? Good. Definition of congruent polygons. Remember, you are not allowed to abbreviate, but you can use symbols. So you can use those angle symbols, congruent symbols, any symbols we've learned, parallel symbols, perpendicular symbols, but no abbreviations for your words. Questions? Okay, how many proofs are left? 2? Okay, I'm going to look and see which one I think is the hardest, just in case we run out of time. Let's do the last one, and we'll come back to the next one if we have time, okay? So I'm going to skip this one for now, and let's go to this one, okay? So again, they're just all the same process. No matter how many proofs were in your notes, we could do these all day long. It's the same process. You're just going to have to use what you've learned previously from today in those postulates and theorems and definitions. But I'm trying to do several examples that will remind you of some of the theorems, like right angle congruence theorem, vertical angle theorem, third angles theorem, things you might use a lot. Okay, so first thing we're going to do is write down our given, one step at a time. MK bisects JL. Number 1, given. Go to your picture. This is kind of crazy looking, don't you think? Okay, so if I were you, I might want to redraw that picture away from all the busyness of everything else in the picture. And then relabel J, K, N, M, L. And then when you look at that picture, do you see just 2 triangles? No. So now the next thing I would suggest you do is look at what you're trying to prove. Which 2 triangles do you want to be congruent? So which 2 are they talking about? Okay, so that's the top triangle, JKN, and LMN, the bottom triangle. So that's where you want to focus in on getting 6 parts congruent. Make sure that you don't start getting other things in the picture congruent that aren't needed for your proof. So we want these 2 red triangles to be congruent. We are given that MK bisects JL. So what can we say is now congruent from that? We just did ones just like this. If MK bisects JL. Okay, JN and LN, because JL is what is being bisected. So it's being split into 2 congruent parts. So number 2, JN is congruent to LN. What was the reason? Good. Be really careful that you're using the right name as far as whether it's a segment or an angle. Definition of segment bisector because it's a segment. Okay, going on to our given again. We have JL bisects MK. Number 3, given. And I hope you're seeing that it helps to do one at a time to kind of process what does this tell me. So number 4, if JL bisects MK, what can we now say is congruent? Very good. MN is congruent to KN. Splitting that line segment into 2 congruent parts. So MN is congruent to KN. And again, the same reason, definition of segment bisector. All right, and then we go back up to our given, and another thing they tell us, number 5, is that JK is congruent to ML. So let's mark that. JK is congruent to ML, and that was given. And so at this point, we have all 3 sides marked congruent. Agreed? But we have no angles marked congruent. And we have one more given statement. So I'm going to go back to number 6, and I'm going to come up here. Since it's getting kind of low down here, it's hard to read. So we have JK is parallel to ML, given. Go to your picture, mark that. JK is parallel to ML, so that means this top line is parallel to this bottom line. How does that help us if we have 2 parallel lines there? Think back to the last chapter.
Angle K and angle M would be alternate interior angles, so they'd be keep.
Very good. The only problem with that is since there is more than one angle at angle K, we would have to use 3 letters. So you are correct though. We could say this angle K would be congruent to this angle M, but we'll need to name it with 3 letters. Does everybody see how those are alternate interior by this transversal MK? Okay, and again, we'll have to use 3 letters, so we'll come back to that as well. So right now, let's focus on these 2 angles. How can we name those correctly? Okay, I heard angle, so this is number 7, sorry. Angle JKN is going to be congruent to angle, very good, LMN. It's JKN and LMN, if you can't read that very well. What's the reason that we know that? Say it again. Exactly, Matthew. Alternate interior angles theorem. Not the converse, because we're not proving lines parallel. We were told the lines were parallel. So it's just the theorem. Sorry, that should be a 7. I don't know why I put a 4. Alternate interior angles theorem. And then I don't know if you heard Weston or not, but he said that using the same reason, we could also say that angle J and L were congruent, because those are also alternate interior, but we're using the transversal JL. So if that's the case, we need to again use 3 letters to name those 2 angles. How would we name those 2 angles? Okay, so angle NJK is congruent to angle NLM. Is everybody with Anna there? So she did NJK, NLM. Those angles would be alternate interior also. So if I were you, I would probably just put them all on the same statement 7 for the same reason 7. That way I don't have to write my reason twice. Is that okay? Okay, so now we have 2 angles marked congruent and 2 angles marked congruent. So what's missing? Okay, so number 8. Angle JNK is congruent to angle. How does that match up? Way I remember it is you started with the one that had 2 marks on it. JNK, so what's it going to be? We got to start down here where there's 2 marks. LNM. So just look for your markings. If you're marking it correctly, that'll make it easier. Angle LNM. Now, why are those congruent? Okay, could be vertical angles theorem. What could be another reason? Third angles theorem. So it could be either reason because they are vertical angles, but they're also the third angles that we're marking congruent. And it would not matter which reason you listed. I'll put vertical angle theorem just to remind us that that is one of our theorems here, but it does not matter. And then the last step, because now we have all parts marked congruent, number 9, we can say triangle. JKN is congruent to triangle LMN. And what is the only reason today that we can prove the polygon's congruent? Okay, definition of congruent polygons. So if we're trying to prove 2 polygons congruent, there should be no guessing about what is my last reason. It's just, can you get all 6 parts if it's triangles or all 8 parts if it's quadrilaterals before you do that? Questions? Okay, how you feeling about the proof so far? It's not bad, right? This is more procedural, and it will be the same Wednesday and Friday, procedural, but we'll learn some shortcuts so we don't have quite so many steps and maybe not quite so long of proofs, okay?